Okay, my mic's kind of tweaking out. Sorry. We're back with some more OCamling. So in the last video, which was yesterday, um, probably should move myself actually. Whoopsie daisy. But in the last video, I implemented variables, which is very cool. Variables for my thingy. So you can now do like you can like assign values to identifiers. But the rule that I specified was that you can only have identifier starting with lowercase letters, and that is because I wanted to add some more to keep some more room for adding other features. So in this video or in this session, I'm going to at least add constants like pi, Euler, and these constants will start with capital a capital letter. I might even make them uppercase, like pi uppercase, capital P, capital I. But I'll see. But I mean, yeah, we need to add pi, Euler's constant. Um, I don't support imaginary numbers. So I won't be adding that. Like I. Oh, that actually would be quite interesting to add. Interesting to add. But yeah, I think it's just that really then. Pi and Euler's form, Euler's constant, and maybe I'll also add an operator for. Well, okay, no, because like the other thing I'm thinking of doing is um adding functions. So I'll see if I get to that as well. But anyway, first things first, let's go ahead and implement some constants. Should be pretty easy. So I'm just gonna open my project. CLI calculator. Nice. We are in. So let me just make sure that my thing isn't covering. Should be fine. Just so you can see my keybinds down here. And yeah. So to do this, we need to start the part at the tokenizer. So lib tokenizer. And we're going to add a new thing, which is constant. Because like I could check it later, like check if the identifier is a constant, but I might as well do it at the tokenizing level, right? Because like I'm just like if I'm just processing the text, like I might as well just check if it starts with a capital letter or not, because I'm enforcing the rule that if it starts with a capital letter, it's a constant. So yep, constant of string. I may even be able to just substitute it directly. Would that be good? I think I will. Yeah, I mean it's a constant, so you know what? I'm going to just define it here, and then just substitute it here, which means I'm not even going to store this. I'm just going to substitute it as a float directly. So in that case, I'm going to create a new file called constants.ml, and it'll just be let constants equal, well, it'll be a string array. It would be a hash map. Now it'd be a hash map. So string hash table dot t, key is a string, and the store is a float. Yep. And I want it to be constant. So how do I initialize? The thing is, I mean, I assume that OCaml works out is that once you initialize a variable like this, you don't need like it won't reinitialize it each time you call it. That's my assumption, because that's what Haskell does, and I had to learn that the hard way because I tried like optimizing it and then I realized, oh, I don't need to do this. How should I go about populating a hash table? Do I need to worry about it being reinitialized every time I access it? Because like if I should just like define this like a hash table dot add and like do this, I feel like that would create it each time, no? Which I want to avoid. I mean, for variables, what I do. For variables, I did create. Maybe it's fine then, because it doesn't create each time, does it? Didn't post. So let's go. Okay, well first, let me just change. Oh, let me change this here. Don't need this either for harpoon. Tokenizer, let's add that, and somehow that's just added everything. What? Okay, tokenizer, and I didn't save. Ooh, what's it called again? Constants. Yeah, let's save that and add it. So now we can hook to it. Okay, and then we just do hash table dot create with initial size 2, because we want to add 2 things, which are Euler's constant and pi for now, and until I can think of more, because for some reason my mind's just blank. Is that correct? Yeah, that should be it. Okay. No, hash was immutable, so persistent plates. Just define it once in the scope you need, and then this is called automatically, I guess. Okay. Wait, so I thought this was like just for the entry point of your program. I can do this. This is the idiomatic pattern, built in a local scope, return the finished table. Okay. I'll do this then. So let's let table. Yep. I'll just like this. And then I'm iterating through and just replacing. Yeah. I mean, yeah. So it's list. Oh, it's a list iter. Okay. List iter. We create an anonymous function with t, k, and v. K is the key, v is the value, t must be the table. Yep. And then cool. Oh, because I'm iterating over the list of tuples. Okay, fair enough. So list.iterate with a function key value, because it's of my tuples. So it'd be like key value like this then. That's a tuple. Yeah, because I'm pattern matching it. Hash table dot replace t with the key and the value, and that's it, isn't it? And then I define a list like so. So we're gonna have pi is going to be now I could like import like the maths module, but I kind of want to do it myself. How is how do I access math constants? Ooh. Scanning thoughts. Could totally just Google search this, but whatever. And how is pi usually defined? I wonder. Like, would I just do the 3.14? Okay, looks like it's bugging out. Uh, how to store pi as float or double in code? Let's say. Oh my god. Okay, 3.14 like this. So I'll just steal this then, I guess. No camel math constants live in the float module. That's it. There's no separate math module for anything more exotic. If I just find them yourselves. E is X. Oh, yeah. Okay. Machine epsilon. Uh, I don't know what that is. So I'll just do this. Define it manually for shits and giggles. 3.141592653589793. Okay, that's right. And then, yep. I'll do E, capital E for Euler. I know it's a bit weird. Usually you do it like that, but whatever. Gotta keep it uniform here. 2.7 something. Ref math Euler. What? Where are we? Nowhere. That is great. Euler constant code. Yeah, it's equivalent. It's approximately this, but all right, close enough, I guess. 2.71828. Probably precise enough for most use cases anyway. And I don't. Can I have a trailing thingamajig? Maybe I can, but I can't. I don't know. Also, I should not use square brackets for this. I need to use round brackets. Yep. I can just do. I can't. Boom. Boom. Okay. Let me just try with a trailing comma and see if it. Trailing semicolon, see if it works. Do I need to do this? Right, because yeah, because I need to return t. Funky, funky. Yeah. Okay. Let's duplicate this. And I can't compile yet because I need to actually implement these. Well, I guess I don't yet. It should at least compile just to check that it does compile. June execute, please. Why does it like seem to recompile everything each time? Unbound module hash table. Did you mean hash table? I did indeed. On what line? Thanks for telling me. Here. Hash table. Looks good. So now to actually implement it. So yeah, when is digit, when is identifier. So we're going to add a new one. C's when is constant. Let a constant remaining equal. In fact, I'll put this above for reasons that will be obvious in a second. Parse Can I do parse identifier? Take while condition, and condition includes everything, right? Yeah, it does. So should be okay to use the same thing then. Parse identifier C's in token map token dot number, and the number we're going to get is assuming it exists actually. So if hash table dot mem constants dot constants constant, Jesus Christ, then this, right? Else error unrecognized, or yeah, undefined constant constant, right? Because this returns a string, I think. So that should be fine. Put this on its own line there. Otherwise, look at the map hash table dot find constants dot constants constants dot constants constants. Yep. And remaining. And let's just do let. Can I open it here? Open constants. You know, it doesn't matter too much anyway. Right, let's just compile then. See if this works. Line 71. This might be unmatched. Probably is unmatched. It is unmatched. Okay. 66. Unbound value is constant, right? So let's define that. Put it here, I guess. Right, so if it is a constant, is constant, then we actually want uppercase chars here instead. So boom, 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 uppercase, and we'll change this to just capital A. Constants must start with a capital letter, and the rest is the exact same as this. Just gotta change this here. Okay. Should work. I believe that's it. It looks like it compiles. So if I just do pi now, I get 3.1415, and you can see it's being tokenized as a number. If I do E, it's this. If I do the area of a circle, so if my radius is 5, I have to do 5 pi r squared. So pi times 5 squared, 5 times 5. Awesome. We love to see it. And then if I have an invalid constant, like phi is undefined. If I do touch a sign one, so phi like this, undefined constant doesn't work, but I can do this. That's fine. So I can do like phi times pi, but I can't do phi times pi with a capital P. Nice. That is it. Yep. I don't think there's anything else, right? Pretty sure. So we'll just commit this. Implement constants with pi and Euler's constant. And then let's push. And then let's go ahead and update the README as well. So, yeah, README, a bit laggy there. Pi times, or 5 times 5 times pi. What does that give us? So I can use it as an example. 5 times pi gives you 78 point whatever that is. So paste. Cool. Constants starts with a capital letter and cannot be assigned to. I would say uppercase letter and cannot be assigned to. The current supported constants are, and then we'll probably have to make a list here. So we got pi, which is this. So that's annoying. Yeah. So we got pi equals boom. And we've got E Euler. Yeah. Just wrap this in backticks. Okay. So we got pi and Euler's constant. E. Well, not really necessarily. Okay. And that should be below this. My bad. At this point, I might as well just do this. So operators. Variables. And constants. Yep. So pi times 5 times 5 is valid. Phi store. What even is a phi constant? I mean, I guess I might as well add it. So something else like foo 3 invalid, cannot create constants, and you cannot do like 3 times, I don't know, different number, 7 plus my num, or like 7 plus, what's like a funny thing I can do here? I don't know, Jim Bob. Invalid constant, not a constant isn't defined. Okay. Yeah. So these are compiler defined constants. All right. Git add once again. Git commit. I'll just update readme with constants. Nice. Cool. That was pretty easy. Could I use the tokenizer to do it? Yeah. Yeah, I mean, if I can use the tokenizer there, why not, right? Makes sense to me. So now, that took about 20 minutes, not too bad. Now I want to see if I should bother adding functions. I think before I add functions, I just want to add a few more operators. So I want to add exponents. So let's go back to the tokenizer. Don't need constants anymore. Yeah. So we're gonna have a new constant, which is a new operator, sorry, which is this up arrow thingy. That'll be token map. Token dot operator plus minus asterisk slash. What do you call this? A caret, right? Caret symbol. Yeah, caret. Okay. So caret sees, and then we need to add it as well here. Caret. And actually in comments, I'll add some info here. So plus yeah, minus yeah, okay, that's a bit dodgy, I guess. Slash and caret. Add some bars here, so it's a bit more easy to see. Speaking of bars, I wonder how I would add like what do you call it? Absolute value. Okay. Also, if I want to add, yeah, I was thinking. I wonder if I should try adding boolean, boolean stuff like boolean logic. Like I could just have it return ones and zeros, right? Is it instead of true and false? Okay, I think I'll do that. But then I need to add equality, which needs to take a left and right hand side. But if I just put that at a lower precedence than other operators, then it should be fine, because I guess if I were to last, right? Okay, I'll look into that. But for now, the caret. So let's go to our parser, multiply, divide, what do you call it? Raised to power? Yeah, I call it like power, whatever. Yeah, what? Verb for exponent. Exponentiate. Fine. Exponentiate. I like it. Sounds cool. So let's go down. It'll have the same precedence as, no, it'll have higher precedence than multiplication and division. but also, would it be higher than these? For the negative should have lower precedence, right? Because I mean it's ped mass. So in ped mass you have p for parentheses, e for exponents. Negative numbers is a bit more like arbitrary, but usually you attach it to the number itself. So it's like part of the number. So in that case, a negative should actually have higher precedence. Like -2 squared, like this. I would expect this to be, like if you had 5 times -2 squared like this, right? Okay. I would expect this to be evaluated like this. Or would I expect it to be actually like this? I'm trying to think what I'm used to. Let me try my calculator, see what it says. So if I try doing 5 times -2, that's fine. If I do 5 times -2 squared, I get -20, which means it's treating the exponents. Okay, so in that case, the exponent has higher precedence. So I need to separate minus to its own layer, I guess. Whoop-ba-ba. Okay, then, so we'll create a new layer just for negatives. Get wrecked. We'll call it layer 3. So we need to update the other one to layer 4. And this will be just negatives. Yep. Okay. Whoops. Please don't highlight. Oh, I can't spell. Okay, so, and parse L3 rest. Just gonna copy this. So I just copy this, right? Should be fine. Delete it even. Yep. Otherwise, just T? No, otherwise just continue. So left tokens. Okay, left tokens. That should work perfectly fine. Then need to do and parse L3 as well. So I'll just copy this. This is L3, so we'll do parse L4, the next level, L3 here. Good, that's it. And then here we're going to change this to level 4. That parses L1, that's fine. That's fine. This parses L3. Is that right? No, this should go this parse L4 first. Okay. I believe that's it. Looks good. So parentheses, not negatives, but parentheses, exponents, and numbers. Now parentheses have higher precedence than exponents, but because they always come on the left side anyway, I don't think it matters, does it? Like I'm never gonna have okay, let me try this and see what happens because I'm actually not entirely sure. Like in the same way that technically division comes before multiplication, but because like they're associative or whatever the word is, it ends up not mattering which one you parse first. But for like yeah, like parentheses should just work. Anyway, so let's have we're matching what? Number identifier operator. Operator caret on tokens. Yeah, let's just go down here so I can actually what the hell, so you can see what's going on. So it's let expression rest equal, we'll parse L4. Yep, so if you get a caret, then if there's any parentheses, you want to include that. So that seems logical. And then just OK expression dot binary op with the exponentiation or exponentiate expression rest. Right? That should work. And then we just need to go ahead and add it to our evaluator. So we got divide and exponentiate, which is a function x of y, or x and y, and it returns, yeah, so is there an operator for that? OCaml exponent. Float, float. Exponentiation. Exponent. 1, 2, power. What's the difference? Base 2 exponential function. Huh? What's exp versus power? Power versus thing power, which is 9. Math exponent computes e raised to a power. Oh, that's right. Yeah, I remember that. Okay, so can we get an example? Actually, do I even need one? I guess I just do float dot power of x, y. In which case, I should don't need these. Seems good to me. Just need to add those there. That's it. So git. No git yet. No errors? There's definitely an error. Yeah. Syntax error. The constructor expects 3 arguments, but is applied here to 2 arguments. Probably because I don't have a. Wait, where? In the parser. Line 35. Right, I need left. Yeah. It's a tuple, so it's matching this. Is that right? Uh, yeah, that should work. I'm wondering where's the tuple even coming from? Like, why doesn't this also match a tuple? This takes a tokenizer list. This takes a expression t and a tokenizer list. Why is that? The users don't really care, do they? So I need to change this. This also won't work, will it? Uh, uh, when I parse L3 before, I just did tokens. Parse L2 tokens. Parse L2 tokens. Yeah, so L2 just takes a token list. Parse L2 rest and parsed. I see. I see. But there's no parse L4 in this case. I mean, there is, but like there's no parse L4 rest, I mean. Um, so I could actually change this. Uh, okay, we'll just do this cleanly, I think. So we'll do this. Say we don't care about the what's there. And then for the exponents, I'm gonna need this. How do I do this? I'm passing just tokens. I need to parse. I need to pass the left as well. Where's the left even coming from? The parse result. Ooh, 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 ooh. So the top layer has no left, but I kind of need it. So do I just parse itself? Like, what do I do? And parse level 4, and then just have this parse itself recursively. That might work. Let me give it a try. I mean, it's hard to like really visualize, but so change this to the parse L4 rest. I mean, this would just call itself though. That's the issue. Hmm. I mean, okay, so I mean, the easy option is to just create another layer, layer 5, where I only have parentheses and numbers at the top, and nothing else. Is that worth it? I think that's probably worth it, to be fair. And then it also just makes sure again that the exponents don't mess with the parentheses. So layer 4, which will be exponents or exponentiation, right? Um, yeah. So I'll copy this. Parse L4. We're on level 4 now. And here we're gonna parse L5. Crazy. I got 5 layers. 5 layers deep. So remove this. Parentheses, variables, numbers. So this is now L5. And this gets moved. Should be okay. Okay. Um, parse L4 rest. So this should be parse L5 rest. No, it doesn't exist. Parse L2 rest. No, it calls itself. Okay, that's fine. So then, yeah, so parse L4 rest. Anything else? I just use tokens here, the full name for some reason, but I don't use it anywhere else. Bit strange. What? I'll call this tokens. I shall just match this. Okay. Yeah. That's it, right? No. So for this level 2, it would do parse L3 tokens. So I need to call here parse L5 tokens. Okay, now it should work. Fine. And then this is also fine. Right. This should work. Except I need to change this as well to parse L3 rest. And let's see if I forgot if I forgot anything. This pattern should not be a list literal. The expected type is expression T. Whoopsie daisy. That should be here. Syntax error. Oh my god, I'm using whoopsie daisy, wrong language. So this is in the evaluator. Whoopsie. Let's just put this in functional style. I am a bot. And that should compile. Okay, so 2 to the power of 2. Well, I'll do something a bit more obvious. 3 to the power of 2 should be 9. It does indeed. And negative 3 squared should give me negative 9. The next with a token. Okay, so now negative isn't working. 5 times negative 3. Okay, I need to fix that. By itself should be an error. Like this is an error. Yeah, seems to work. 7 squared. 3 plus 3 squared should give me 12. But if I do 3 plus 3 squared, should give me 36. If I do 3 to the power of 1 plus 1, should get 9. Nice. So, why are we getting an error in the parser? Right, so for the negatives, we're getting an error that you can't have this by itself. Why is that? Why is that? This should accept everything, so that should be okay. Even if that's an empty list, it should be okay. Um, what was it saying? How does this even catch unexpected tokens right now? Like, how come I don't get errors all the time? Is it because the call chain propagates upwards to parcel 5. So if it doesn't find any of these, is it because it's a number? Yeah, like a number kicks it off. So it expects a number. Oh boy. So how do I do that then? Because this just calls L4 directly. If this gets called, no, because it parses before this is ever called. That's why. Um. Ooh, how does this work with precedence? This is difficult. This is difficult. Oh, and by the way, the reason I think the negative number, like negative 2 to the power of 3, I think the reason that isn't negative 2 in brackets is because a negative is treated on the same precedence as multiplication. In which case, I could actually probably merge these, but first I need to fix this issue. Yeah, dude, this is unexpected. Um, I can add it directly here, I think. But it means that the thing is, if I match it directly, then it's going to have higher precedence than everything else above it, which is not what I want. Mm, missing closing parentheses. Like this part is L1 tokens. I guess I can treat negative as a parentheses opener. But like then like when does it end? Like it ends kind of arbitrarily because it depends on what the precedence is of operators after it. Oh boy. Yeah, I don't know. I'm actually completely stumped here because it's going to like okay. So the question is, if I were to sidestep this error for the specific case of the negative sign, how do I like what do I do with it? Like, cause like I could just add this here. Uh, okay, I guess let's just try first of all. So if I have an operator minus, what like what do I do here? I've caught it. I can't like expand it because the minus needs to have lower precedence. Uh, hmm. Maybe I just call level 4 parse because like here it's L1, but if I just do L4, then it should come back up here. Maybe. Let's try. Let's expression rest equal parse L4 tokens. Level 4 being the exponentiation, and above in begin match rest with. But I don't match it, so I can just do rest in OK like this. Will this work? But it's not that though. It's gonna be returning what? Returning this. Alpha tokens. And it'll be okay, I think. Will this work? I feel like this will work. So let me just skip this. So for L2, we'll just skip to L4. So this code is never actually run, and I'll just confirm that by commenting it out. So the compiler tells me if I call it. Let's see what happens here. Syntax error. Whoops. Parcel 3. Undefined. Line 68. Yeah, so L4 here, L4 here. Okay, this might work. So -2, -2. That's fine. 5 minus 2, same thing, obviously. I mean that's a different operator. So now if I do -5 times 2, -10. Correct. But -5 squared should be -25. Yes, I'm a genius. Come on. So that's it, right? 5 times -3, -15. 5 times -3 to the power of 2 is 5 times 15. 5 times -15, sorry. Yeah, I guess we're done. So let's just try something else then. -pi, -pi squared. Awesome. Cool. Looks like that works then. So I'll delete this layer. Um, I should probably like make a better system for this, like because like having to manually rename it each time is a bit of a hassle. But I don't know. I'm not entirely sure what I can do, to be honest. I guess like instead of numbering them, give them actual names. But then what do I name them? Because like the thing can change. Um, sorry, 4. Parse L1 operator parse layer 3. I don't know if this will pick up the errors if there are any. Yeah. L3 L3 parse L4. Don't get stuck. I should probably set up testing on this, but whatever. Seems to work. Oh, cannot parse tokens. Where did 5 go? Oh, what the hell? I can tokenize. That's weird. Why can I do that? Okay. Um, exponentiation. Is this wrong? This should be L4, shouldn't it? 5 squared. No. Well, that was a mistake, I think. But it still doesn't work. Oh boy. Okay. My back. Oh, my back. Okay. Let's just leave this for a second. Yeah. To add some tests. I want some tests. So let's have a look at what Claude said was the way to write tests. Here. Oh, we're including alco tests. And I need to install it. So OCaml install alco test. Yeah. And in the meantime, let's go to test, I think. Add to your lib/June or create test.june. Yeah, we're doing test.june. Name test calc, sure. Just include the libraries. Libraries calc. Libraries. Oh no, I list them. So calc and alco test. And then in test.this thing, what? So for example, let test.addition, test addition, for instance, is said, which just takes an empty argument. alcotest dot check int. Alcotest dot check int. Oh no. What is this? Like with external libraries, like because it's ML, I don't actually know what's normal ML, like what's been like Lispified to be custom. Check int. Um, I'll do OpenCalc, which is the name of my library, and I believe I do just calculate, right? So check int. Um, Float even. Check float. 1+1, I guess. Um, Pass in the input. Well, okay, now, so the input. So calculate or calculator dot calculate, right? Um, to 1+1, and then that should be 2 dot, right? Is it done? It's done. So if I try, no, don't do it again. Okay, so now if I try running, no issues. So how do I run my tests? How do I then run my tests? Because I assume it's not automatic. Structural equality. Token.pp, token.equals. Huh? What is token.equals? I don't know what that means. Alco test, check, let's token testable. Yep. Okay, June test. Unbound constructor open. Is that meant to be a keyword? Sorry. The value of float is type float to float testable, but expression was expected of type. Okay. Check floats. 1, 2, 3. Did I not do it correctly? Oh, sorry. The expected value is on the left, like so. And we'll do like this for readability. The value is type float, float testable. Token testable. Huh? I'm confused. Check int. This. What's wrong with that? This will fail. Good for seeing output. Yeah, I'll go test dot just check string. Yeah. So why can't I just check float? Um, what's wrong with this then? Am I dumb? Tolerance parameter. Floats aren't compared exactly. Okay. The E is the acceptable difference. Oh, so in the error message it was saying I need another argument, I guess. Man, that is not a clear error message. So check float. Yeah, sure. 1E minus 6. I'm not even sure I need that level of precision, but if it works, it works. This expression is type float string results. That's right. So what I do? Yeah. how do I do this? What if my output is wrapped in a result? I assume I just like. Actually, I don't know. I actually don't know. Check results. Okay, so results like a special thing. Fine. So what? Results, float, and string. And then I just pattern match it, I'm guessing? Like, okay. Yeah, exactly. So I'm expecting okay 2. Okay. No things. Can I like, get the verbose output? To force output even on pass. Yeah. So do test force. Great. I run June test force, but still nothing printed. Run the test binary directly. Oh, there's a test binary. Okay, test slash test main test calc.exe. Okay, whatever. Right, so that's fine. If I were to change this to like 3, I should get an error. Or not. Hello. What? 5? What? It's recognizing the difference, but it's not really comparing it properly. Um, yeah. If I change to an incorrect value, it's still uh the test passes fine still. Why? What is going on? You probably haven't registered the test case and lcast.run. The function exists but is never called. Check that you have something like okay. Did it say here? It did say this here. I'm just blind. Whoopsie daisy. So let's okay. Allo what's it called? Alco test. Why is it called alco test? Dot run. Let's give it a name. Um tests. I don't really care. Okay. And then we just give them names. So addition. Alco test dot test case. Uh addition. So I guess I got groups, like multiple groups then. So I'll just call it addition twice, I guess. Um what's quick test addition? Okay. It works. So if I change it to 3 now, I should get a failure on my test. Yep. Nice. Nice. Okay. So let's how do I can just use an anonymous function here, can't I? Instead. Because I don't really want to have to name all of these. Um so let's do a function empty to this. Oops. More or less. Yeah, just remove this stuff. And do this, I guess. Okay. Looks good. Yeah, that works. Okay. So then I can do something like this. So let's expression 1 equal 1 plus 1, case 1, example 1. I'll do case 1. Case 1 in, and then I can just kind of do that like this. That should work. Okay. And I could even, okay, let me call this the evaluator. No, it's not the evaluator. Well, I guess it is. Whatever. So I can delete this. Can I abstract this to a function? Like just like let uh, eval test, I guess, equal. Sorry, it takes a string, right? So case string and or well expression string, be more specific, and a result expected, and then just say it's alco test dot check results float 1e minus 6 or string, and yeah, so just case 1, not even case 1, expression expected calculator dot calculate expression. Yep. So then I can just do this. Eval test case 1 and then 2. Semicolon. What's wrong? Oh, closing bracket. Do I even need this? I shouldn't do. Expected. The value expected as type float, but expression was expected of type float string. Oh yeah. Um, float string results. So we're matching against okay. 2 like so. I can even just have this be a function, can't I? Like this. And then I don't even need to have this. Yeah. Quite useful the way you can just substitute functions like that. Um Looks good to me. Just this is the other thing. In fact, I can abstract the entire thing. So I guess it makes sense to just do alcotest dot test case expression quick, and then just do this, right? And then I don't need any of this. I don't need this either. I don't need any of this. I can just have this. Unbound module alcotest, a locotest. Alcotest. Case one's not named. Wherever case one here. Yep, so just changes to the thing. Sounds. Just works. And then do this. See if it errors when I want it to error. Yep. Nice. It says, yep, expected 3, received 2. Perfect. Done, right? So we'll do 1 plus 1 is this, and then we can just kind of chain these. So like, I don't know, 9 plus 8 is 17. Yep. 9 minus 7 is 2. 9. Okay, that's 9. Let's do 6 times 3 is 18. Just testing all the numbers as well. See if it works. 6 times 3. 8 over 2 is 4. Let's do can I do a for loop? Because I want to test all the digits from 0 to 9. I mean, I could do like eval test 0. Whoops, 1, like this. No, but I want to test it for like more than just that, because this is also double digits to take into account. So yeah, so I guess the best way to do it is to just test this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. Check if that's equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 0 point, right? Shouldn't be too big. Yep. Okay. Eval test 5 squared should give 25. And likewise, negative 5 squared should give you negative 25. And I think I need to wrap this. Nice. Yeah, so from here we can see that 5 squared is not working. We're expecting 25, but instead we get an error. Nice. Also, if I don't run June test, if I just do June execute, does it? No, okay, so it doesn't give me any errors. Will June test catch errors in the rest of my program? It must do. It must do. Okay, so I'll do June test then. Same as like cargo test, right? Nice. That's our evaluator. I could test out other stuff, but should be okay for now. So, okay. Is that it? Variables? I could totally just define a range for this, can't I? I might do that. What did I do just now? Sorry. Where was it? Constants. I did list iter with a function. So I'm just going to copy this, my own code. Thank you very much. And let's just do this here. So we're going to do a list iter, but our function is going to be take the expression and the expected, and then do eval test on expression expected. Okay, actually expected. I'll do that. Yep. So then I can just actually. I mean, this should work for starters, right? So if I test has type expression was expected of type unit. What? Oh, yeah, it didn't really specify the types here. Expression is a string. Expected is a float. I can't do it like this, really. Okay. Where do I put it then? Can I even? I should be able to. I think I have to do it like this. And let's just do it like this as well. Okay. How the hell? What? What does it even do? Um, has type unit allocate test expression was expected of type unit. So I can't. Of type unit. Why is this? Is it returning something that it shouldn't? Um, do I need double in this case? Is that why? No. Why is this working? I'm very confused. This closes this, that's fine. Closes the whole line. The expression is type unit alcotest.test case equals on line 14. So this needs to return unit somehow. How do I make this return unit? I don't know. But why isn't it okay? Because this returns it. Can I just do this? Non-unit statement. This expression should have type unit. Has type unit, but an expression was expected of type. I see what the issue is, yeah. Okay. This is over my head. Let me see if Claude has any bright ideas. Can I get this list thing to work? Uh-oh. Oh well. Okay, so it doesn't work. Damn it! Damn it to hell. Okay, well that's fine. It's not that redundant. Do I want to actually? This is a val test. I think I will. I'm gonna change this from a result to just the float, so I can just do okay expected, and then I don't need this anymore. Oh boy. Boom, 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 boom. Uh, okay. And here, okay, didn't write it. Eval test. Just remove these and remove these. Should get the same error as last time, which was the 5 squared error. Yep. Okay. And yeah, yeah. I'll do variables as well. So like x to 5 should return 5. Um, ooh, does it maintain order? It might just do that. So let me do 5 plus x, or like 3 plus x then, is 8. Let's see if that works. It worked, yeah. Okay. And then let's add eval test. 3 plus y, which should be an error. So for this, I'm going to have eval test, but for errors, which wants a string. Tell you what, I'll do like this. So I'll create a base. And I actually won't even bother with this, but I'll make the OK. Yeah. So this will just be this, and it will take the result. So float or a string result, like normal. And this one will just be eval test, expert, OK, expected. Yep. And let's just remove these because it's pretty obvious at this point what the type is. Hell. Okay. So change all of these. So boom. Control Q. Insert. OK. But for this one, we don't want this because we want to test if it's an error. Error something. Ooh. How do I How do I have like just any generic error? This will fail, but what if I want to check if it fails? How do I just check if a result type is an error without caring about its content? Do I just use a like the empty patch and match thing like this? 3 plus y error? I assume not. Check bool is error, result is error. Okay. So let's eval test error with our expression. We need something else here. So the expression is just a string. And we want to do alco test dot test check bool. That's a name. So expression is a name. True is true or not. Result is error. Okay, so result dot is error. On calculator dot calculate that. Yep. Okay. Yeah, that's fine. Okay. So eval test error. P plus y. So does it error? That's the question you want to ask. Type units, expected type of type unit, algo test case. What? Man, this is wacky. What's wrong? Is it returning check bool? No? Oh boy. Oh boy. Come back to me. It has type units, but it wants something. Oh, am I missing like quick or something? I must do B. Am I though? Let's add it just to see what happens. Oh no, because I need to add the. Ah, my god, I'm something. Okay. This would be function. Not even. Yeah. So function like this, and then we have alco test dot test case. There we go. Yep. Okay. Test. Looks good. So we want an error as well on 3 plus phi, or we could just do foo. But eval test okay. Well, no, because we've already checked that the constants exist there. So then we can't define foo either. And let's put this above just to make sure it hasn't like been defined. Okay. That should suffice. Because then we cover constants, variables, and everything else. Cool. So cannot parse tokens, tokenizer caret, and the number 2, which is a bit strange. So let's go back to our eval parser. Is it a parsing error? It is, right? Because it is here. Could not parse. Could, yeah, here. Could not parse tokens. So why is that happening? It does work for negative numbers, which is also weird. So here, I feel like it might be skipping something now. Parse L3, parse L3, parse L3. This is skipping. Do you chest? Nice. So if the test passed, then I can just assume that my thing works, right? So we're good. These will work. Nice. So I'm going to git add again, git commit. So what we got? We need to. What do we do? We added the exponentiate operator. Oh my god, can't go talk it in the imperative tense. Add the exponentiate operator, caret, and set up tests. Nice. What are we on now around? An hour and a half. Awesome. Cool. So now we've just added a new operator, just like that. Um, I think that's all the basic ones too. I mean, there's a comma operator, which I don't even know what that's for. I could add like the C comma operator, but I'm not doing that. Although it actually would be kind of funny, but it's useless because you can't assign, so there's no point. Um, maybe I'll add it. Maybe I'll add it later. Just for fun, like it just discards the left and outputs the right. Um, yep. Caret plus divide minus plus negative store we have already as a statement. There's special ones like, well, no, like it's not operators, it's just a button. Parentheses. Square root would be a function because there's no square root key on the keyboard. That's like easy to use. So yeah, as far as I can tell from looking at my calculator, we have everything we need until we add functions. Uh, so I said I would add Boolean logic, so I'm gonna try doing that. Should be pretty easy actually. My keyboard, we got percent sign. A percent operator could like convert a number to a decimal, so just divide by 100 basically. Should I do that? I could add that operator too maybe. How'd that work? It'll be a postfix operator. So it just disregards to the right side, basically. I have unary operators. Yeah, should work actually. But it have to be immediate, so the precedence would have to be on the same level as the negative sign, really. Yeah. And then if you do like 100 squared percent, that should also be fine. Okay, so let me add the percent sign first then, because I want to see the postfix operators. Other things are dollar sign. I can't imagine what that would do. Hashtag doesn't do anything. At sign doesn't do anything. Exclamation mark. Oh, factorial. Ooh, should I add factorial too? I might have factorial as well, which is also postfix. So let me add the percent sign first, because that's the easier operation anyway. So tokenizer, percent, which is of course just this, and yep, just add it to our list here. 0%. Sorry, it's a char. Token map, token dot operator, percent C's. Love it. Then for our parser, you'll have the same precedence as negative. Oh, I actually added it back here. Negatives. Yeah, so what it will do is it will. The thing is, it needs a left side. It needs a left side. So I do actually need it to be like here. Can I put it on the same precedence as a caret? I can, because it goes left to right. So if the caret's on the left, then it'll take precedence, which is fine. So I should be okay to add it here. So exponentiation and percentage. So we'll do left operator percent and tokens. Let expression and the rest. Thing is, we don't care about the rest. In fact, yeah, we don't care about the rest. So I don't think we need to parse L4 tokens here. I think we can actually just ignore the rest and then just go straight to this, which is L3 rest expression dot unary op. We'll have the I need to define it. So unary operation negative has a new friend. Negative and percentage, I guess I'd call it. Yep. So unary op percentage, right? With the expression, the left expression. So in this case, just left. No need to parse anything, and the rest is just the tokens. Yeah, that should work. So then let me just add it to my tests. Okay, whatever. So we're expecting eval test. Okay, 100% should give me. Sorry, 100% should be 1. Yeah, and 42% should give me 0.42. Eval test okay as well. 50%? No, I expect 5 squared percent to be 0.25 because it's 25%. And then I actually need to add errors for these things, like eval test error, like 1 plus plus 1. What is your 2? Plus 2, like this, should be an error. 5 plus negative 2 is fine, but like not like this. Okay. Likewise here, eval test error, just like %2 should be an error. Okay, let's go back to our parser. This is done, I think. So we can go to the calculate evaluator. Just add the function here. So get unary op percentage function x. We just do okay. X divided by 100. That's safe because 100 is the denominator. Cool. That should literally be it. So let's go CLS and run our test here. So June test. It should also give us any compiler errors, just general. Yep, I got a typo there. Percentage. Boy, do I love test-driven development paired with type compiler type error driven development. 100 dot, my bad. We float. Okay. Whoops. In our test suite. It was good. Any errors? All the tests seem to pass. And I don't need to confirm this, but for fun, percent, get an error, 100%, 1. So if I want to do like, if I want to find like, ooh, what is 100%, like what is 50% of, which is times, of 25, 12.5. Let's go. Awesome. Already my thing is now more powerful than other calculators that people have made. So let's git add, git commit, add percent operator. I also need to add update the documentation, but before we do that, let's add factorial. So let's do the test first this time. So 5 factorial should give us 120. And not 5 should give us, ooh, if I want to do boolean stuff, I'll probably should I use the C operators or should I use words? I'm gonna use words like not and so on and so forth. So this should just be an error. Okay. But yeah, 5 factorial is that. 0 factorial is 1. 1 factorial is also 1. And negative anything, so let's do negative 5, for instance, should be an error. Okay, so back to our tokenizer, add yet another operator. I love how like how easy it is as well to add like new stuff. I mean like obviously adding like variables and like functions or like entirely new features are hard, but like just adding like new operators, new constants, like because of how we set up our system, it's just really easy. So fact well exclamation. Is there another word for that actually? Is it a bang? Bang character? ASCII, bro. Bang operator. Yeah. Okay, I'll call it bang. Just because it's snappy. So we've got the bang. And it's if you're wondering why I bother calling these operators by their symbols, it's because I can't disambiguate what the symbols are yet because I don't know the context of their surroundings. So if I see a bang, like it could be factorial or it could be not, right? Or in the case of in our case for like the minus, it could be a negative or it could be subtraction. We don't know yet, so it's good to just keep that ambiguous and let the evaluator handle it. Just realize that this is inconsistent. So let's go to our parser. We need to add factorial. Is there a verb for that? I'm really just making this harder for myself. Factorial of. Factorize. Factorialize. That's better. Factorialize. Should use American English. Parentheses. Negatives, values, and numbers. Should have the same precedence as here, I think. So factorialize or factorialization. Factorial. Who are we kidding? Yep. So pretty much the same thing here. It's operator, bang, unary op, factorialize. And then we go to our evaluator and just add this as a function. Factorialize function x. And then here we actually need to match. So I'll do function like this. If it's x, then, sorry, if it's 0, it's 1. If it's 1, it's also 1. Let's recursive factorial n equal function. Okay, yep. Otherwise, cool. Okay, otherwise, how do I do like a check? Where? When? Like x when n is negative, so less than 0. Should be an error. Sorry, this should be okay as well. So OK1, OK1, error, cannot take factorial of negative value. And then for the other case, base case, it's just OK factorial of n minus 1. So take this, but it returns itself, which is also a thingy. So I need to extract. How do I do this? OK factorial of n minus 1, but that'll be like an OK. Also should be n times, sorry. N times factorial of n minus 1. So do I even need this? Like, I guess it helps like one step. Yeah, I'll keep it. Just to keep it, just keep things efficient. Yeah, so when I call factorial, I need to take it out of its OK, which I guess I can just do like this. Function x, like OK of x, sorry. So many brackets. Yeah, that should work, I think. Is that it, by the way? Factorialize, that should be it. So do test. See what comes of it. Line 20. Syntax error. Get binary op. Why is that? I guess I need to begin function. Begin function, then end here, please. Yep. Parser. The variance expression is expected of type unop. There is no constructor within type unop. Okay. What line? 5.6. Factorialize. Oops. That should be here. Okay. Syntax error on get binary op. It's like, oh, did I not save it? Okay. Evaluator. It's begin function. Oh, what the hell is this? I've got 2. But that should be fine, because that's part of this. No? This is line 8. No, it says line 21. It thinks that this is part of this, but I did function begin function. Should be okay? Huh? Why is there a syntax error? Let's rec factorial equal. Oh, right. In factorial of n. No, because it just no, because it's because of function that takes an n, so it should be fine. Also, no, I'll keep x is fine. Yeah, no, this should be okay. So what am I missing? Begin function like begin match, right? Not match begin, begin match. Why? Okay. Let's ask Claude to see if it can scan this. Why is there a syntax error here? Because I am not seeing any. No, because we got begin and end. So why would it expand? Like there's no begin here, so it shouldn't be looking for it there. Few issues or error is invalid OCaml syntax. Type aliasing to the type parameter. Use postfix notation. What? Float or error, which is fine if you define it the way I have. Okay, function x. The other arms return fun x, but factorialize jump straight into a let's rec. You need factorial returns OK1. Those are int, but your function signature says float or error. Oh yeah. What's the float of a? Hold on. Is there a float of a non-integer? Let's check Google here. Factorial of float. There is a unique good extension to non-integers. Gamma function. 4.2 is approximately 32.58. Is it? 4.2 factorial error domain. Well, okay, I get a domain error on my calculator. So I guess I'll just check if it's an int then. Um, sorry, I'm confused why this doesn't work. Because does this not declare a function that just takes one argument? Syntax error. Still. Yeah, so what the hell? Factorial n. Yeah. Why is it not fine? It is fine. Equals match n with in function of x. Okay, but I need to use result.bind. Okay. I think I don't isn't there don't I have a thing for bind though? Which is just let star. Okay, so I need to have this defined in function of x2 factorial of x. I mean, I know it won't work, but just to fix the parse error, the syntax error. Okay, good. And then let's move this up. Okay, show. Oh, you use 0 or 1. Really? That's cool. Oh, so they fall through. Interesting. I just watched a Reddit article in the same video, the previous video I recorded today, which was about pattern matching in C++, and Bjorn Storstrup, creator of C++, was speculating whether they should have fall throughs. It never even occurred to me to have fall throughs, so that's cool. I would like that if they add it. If they add pattern matching. So I need to bind. Okay, I mean I should know how this works. So rather than do this, I'll do let star. Let n just equal factorial of n minus 1. No, not n, sorry. Let next, and then just do OK next. Yeah. Right? Same thing here. What's this? This says result of bind factorial n minus 1 function previous OK n times previous. Oh yeah, because I need to return a function. No, I don't. Right? And then int of float. Result of bind factorial int of float. Okay. Why? Factorial x just returns a okay. Hey, what am I doing? I don't even need to do this. Okay, let me just define factorial like this. In fact, let me just define factorial as a separate function. Like, okay, so let factorial. Oh, but it can error. That is fair. That is fair. Well, either way, I am going to extrapolate it into its own function. So we'll have n, which is an integer, and if it's not, we get a type error or whatever. So floats, or like I need to convert it. Int or error. Right, so just copy these conditions. Okay. Yep, yep, yep. So it is okay. And we should be able to do this. Shift J, put this here. Right? This is obviously a clusterfuck, so let me just... Yeah, I mean, that's a type error, but let me see if it picks up on this. Any errors in that first. It does. Syntax error, because you just define function. I mean, I don't need to, but I should. So, like, I mean, I could do a match instead, but I don't want to. Right. So this. Parse error. Why? Syntax error. Is it because I have this? Um, let's add begin and end just for clarity here. syntax error on end. Okay, so clearly it's not that then. Why is it a syntax error? I'm returning next should be an int, or it will just propagate the error. No? Oh, I need to use in. Okay, nice. Looks good. So, factorial, yeah. But I need to convert it. So it'll look like this. It'll be a fun x, first of all. I'll also increment these, like normalize there, whatever. Fun x. We need to return okay, but except we're not. How do I do this then? I can first just bind like this. So let results or like factorial. Well, I can't do that, can I? Equal factorial. Int of float x in okay results. Sorry, okay int float of int results. So that's the basic one, and this will just probably implicitly convert. That should actually work, if I'm not mistaken. Looks like it will. It is going to work. What's failing? 25 negative 5 factorial is failing. Expected okay. Okay, the first one. Expected okay 120. Got okay 1. That is not what I want. Probably some goofy thing here. Whoops. What the hell? Because it needs to be n, of course. N times rest, even. Would be a better name, I think. Yeah, so negative 5 does fail. Expected true, receive false. Receive false. What can I see here? Does it no, it doesn't tell me what expected true. It doesn't tell me what it's actually asserting though. Or whatever. So this is not an error. Negative 5 factorial is not an error. Why would it not be an error? Because factorial has higher precedence. That's correct. Factorial has higher precedence. So my test is actually wrong, which is the danger of writing tests, because if they're wrong, then you are cooked. So this should be like this, but this should be okay. Negative 5 factorial should just be negative 120. What's wrong? Oh, classic. Classic ML inspired language thing. All the tests pass. That's good. But we have some issues. So we need this 4.2 factorial should not be allowed. But I'm wondering right now, as it stands, what happens? Like I would think I just do 4.2 times 3.2 times 2.2 times 1.1, 1.2 times 0.2. Oh, but it wouldn't finish. So probably just error. Oh no, because it gets when it does an implicit conversion, or like it does an narrowing conversion, so 4.2 becomes 4 because it rounds down it floors it, which is behavior I don't want to keep. So let's force it to error here. Let's go back to our evaluator. In factorialize, how do I check if I should do a separate one. How do I check if a float is a valid integer without narrowing? Hopefully there's a built-in function. Perfect. Yeah. So I just do if, right? If float.is integer x, then else error cannot take factorial of non-integer value. Um, yeah. And then let's, how do I take a string again? String, float to string? Is it a string of float? And then the float. So x. Okay. In which case I need to just surround these in parentheses. That should be okay. So I'm skipping the tests because I'm a naughty boy. I want to try it hands-on. So if I do 4.2 factorial, cannot take factorial of non-integer value, 4.2. But if I do 4 factorial, I get, that's fine. So let's do a test. Done. So again, git add, git push, git commit even, add factorial operator, and push. Awesome progress indeed. 2 hours in, and we've added constants, percent sign, exponent operator, factorial operator, and now I want to add some binary boolean operators, which should be pretty damn simple, right? So I want to add the equal sign and not equals. Not equals will be, for not equals, I'm going to use slash equals, I think. And then there's no double equals, because screw that. It's my calculator, I can make it how I want. So let's go to tokenizer. We're gonna add some new operators. So we're gonna have equals sign. Not equals or slash equals. Yep. The font doesn't really support it properly, but should I you know what? Because the font says I'll use a exclamation mark. For now anyway. Although if I do 5 not equals 2. Okay, it doesn't even parse it. Doesn't matter. But here, if I were to run my application, if I did 5 not equal 2, yeah, yeah, okay. I guess I have no choice. So bang equals, um, ooh, no, forget that. I said I was going to do keywords. Yeah, yeah. So for the keywords, how do I do this? Because they're different from operators because they just kind of are thrown in there. But I mean, like they work like operators, but they're just tokenized differently. Um, so I guess I'll parse it the same way I would parse an identifier, right? But then I just check if it's something, then like if it's a keyword, then store it as an operator. Okay, so you got operator of operator. Um, I'll just add, yeah, yeah. My system's kind of falling apart here now. Um, yeah, so we'll do not equals, no, not. Yes, we'll do not. And or should I have keyword? I'll do keyword. Type keyword equals. So we go not and or. Those are the three ones we need mostly. Then there's also XOR, um, which I'll add because why not? And NAND. I guess I do like NAND and NOR. Nah, you know what? For now, I'll just do these three. Although XOR is actually quite important because it's more like complex than just not or whatever. I think this was X and, but whatever. People use XOR more often. So keyword of keyword, and then how are you going to parse this or tokenize this? Yep. So this is our is identifier. Keywords are valid identifiers. So you want to check this first. So we got this. So then we just do a match. Match identifier. And I'll do begin match. With. Yeah. So if it's and, then token map token dot keyword and sorry, remaining. Actually, at this point, I might as well just do token map. Put this in brackets. Whoops. Then I don't need to begin. And then at the end, I'll just close the brackets and say remaining. Yep. So our default condition will be this, or our base condition, whatever, or whatever it's called. Yep. And then for this, I just need to do this. Sound. So and or. So just copy this really. I should have not first. Not is the root of everything. Well, this also is, but whatever. And then XOR. Okay. I don't see any reason why this would work. Let's just compile it and see if we get a error here on tokenize. So June test, please. Boom, 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 boom. Unbound value PP keyword. What? Unbound value PP keyword. Why does it tell me where it's where the source is? That's annoying. Unbound value. I did do also add driving show. Keyword. I don't understand what the issue is. That's better. Identifier. Identifier. Okay, so I'm gonna add some more tests. Add some more tests here. Where are my tests? So we're gonna have eval test okay. So like 5 equals 5 should just be 1 or true, you know, whatever. Not 5 equals 3 should be true. Not 5 equals 5 should be an error. Oh, sorry, no, not an error actually. It should be 0. Like it's a concrete value because it evaluates to false. So likewise, 5 equals 3 should be false here. Oh yeah, also like greater than, less than. Okay, I'll add those later. 5 and yeah, it's like 0 and 1 and 1, which is a whole truth table basically, should be 1. Anything else should be 0. So 1 and 0, 0 and 1, 0 and 0. All these should be 0. And also, if I have a 5 and a 3, they should be treated as correct values, like as yes values, whatever. Okay. Then or the truth table for or, so 1 or 1 should be 1. 0 or 1, 1 or 0, 0 or 0. All those should be 1, this one should be 0. And if this works, I'll just assume that this one works. Mind you, they're not implemented the same, so I'll do this. And then also XOR. So 1 XOR 1 is exclusive OR. So this should be 0. Those should both be 1. Yeah. So just copy this. Likewise, for like 3 should be fine. Okay, cool. So now we go to our parser. Not too difficult, just need to do this. So for binary operations, we also have equals, not is actually a unary operator. And or XOR are all binary operators, operations even. And what's the precedence for these? I said that'd be like lower than everything else, right? So like 5 and 3 plus 2 should evaluate to 5 and 5. So I need to add another layer below these, which I will call layer 0 because I cannot be arsed to now rename everything once again. Honestly, I need a better system, like a naming scheme for these anyway. So this will be called the binary operators. Or Boolean operators, but also okay. Sorry, not okay, not. Not should be like not 5 and 2. 5 and not 2. Nah, it should work. It should work without me needing to change the layers here. So Booleans. Screw it. Okay. Just copy this stuff. Same deal. Yeah. Let me just separate this. So we got parse L0, and they call parse L1. So operator, not operator. How's it working in our tokenizer? So tokenizer saves them as a keyword. Okay. So if it's a keyword, if it's a keyword not, yep. Although not should actually be higher precedence, right? Yeah, you know what? I'm gonna change it. I want to put not on the same precedence as negative. So where's negative? Here. So like not 5 to the power of 2 should be fine. But like, yeah. So let me just, in fact, I'll just delete this entirely and just copy this. So operator not. Yep. Parse L3, same thing. Unit operator not. That's the only difference. Otherwise, they're practically identical. So then, yeah, negatives, boolean not, and the rest. And this will be boolean binary operations. Yes, nice. Okay, so we got. I did it correctly. Okay, so here, not operator plus, we're going to have keyword and, first of all, which will just be and. Yep, that's it, right? So we got and or an XOR and equals, actually. So we got equals, should be equals here as well. Or XOR. Okay. Yeah, okay. Cool. That should work. So then let's just go to, first of all, we need to fix this. This should be L0, this should be L1. And this should start at L0. So we'll just skip it. And also, this needs to start at L0 too now. Yep, thank God for my good memory. And then we go to evaluator. So, factorialize is here. For not, I guess I'll add it below this. Go to function x, just return OK. I'll define my own helper functions for this. So let float as bool. Actually, it's probably fine, right? Is there built in? Is there float? Literally a Google search, man. What am I doing? But whatever. Ruminating on it. Sir. No. No. Do you find my own? Well, I thought so. Don't tell me that. Okay. So I'll just do myself then. Float as bool. Takes a float. Just thinking how I want to handle this. I think it's just float. Yeah, float to boolean bool equals function because we're going to match it. So if it's 0, then it's false. If it's anything else, it's true. Is -0 a thing? Hopefully not. I assume it's not. Please no JavaScript. And then if it's bool is float, this is bool to float. False 0, true is 1. Yeah. How did Claude do it? If b then 1, else 0. F is not 0. Which of these is better? Which of these is better? Nah, I like mine better. Screw it. If b, you know what? I don't like this actually. Let's just so we got our f, which is it's kind of obvious what it is. It's in the type name, so I'll just in the bool. Never mind. Return bool if not if not f, then 0, else 1. Float as bool. Sorry, if f, yeah, if f then 1, else 0. So if I do if f, does that convert it? No, it doesn't convert it. So I want to do just f does not equal 0. And then for bool as float, I will take b. We want if true, if false, then 0. Otherwise, 1. Which I can just invert, can't I? If yeah. Okay. Put these together. So for not, we're going to do bool as float, not float as bool x. Yeah. So we're converting to and from. Okay. And for binary operators, we have equals first of all. Oh, did I even add it to a tokenizer? No. Yeah, no, I didn't add it to my tokenizer, did I? Let me just go back before I forget. Yeah, we did the equals operator. I could actually add like the ands for and, like the and sign. But it's just like then what would I use for or? Like for not, you need the neg operator, which doesn't exist on my keyboard. And for or, you'd use the caret, I think even. Or not the caret, like the up. No. You'd use v, and I don't want to make v an operator. So yeah, suck it. If the keyboards were more equipped for maths, so token dot yeah. So I actually made a mistake here then. Not and or XOR, that's fine. But equals is not a keyword. I didn't say it was, that's fine then. But for my parser, I have a feeling I didn't do this correctly. Yeah, the operator equals. Okay, good catch me. So for equals, x and y, just okay. Floats as bool x equals floats as bool y. And I'll just copy this actually. For float as bool x and right, just same thing. Pretty straightforward in this case. or, and then XOR. OCaml XOR. Uh, mod. Oh yeah, modulo exists, but I don't want to use the percent sign for that. No, sir. I could do actually, but usually in maths we don't type the percent sign. It's very much a computer science thing. I don't know why. So I hesitate. Um, XOR, is that built in? Or I could just copy this, but then I need to convert it. Like I'll be honest. So let's just do XOR. X and Y. Yep, that should actually work. Straight up. So let's just test, see what errors you get. Operator not. This variant pattern is expected to have type tokenizer token to operator. There is no constructor not within type tokenizer.token operator. Oh, snap. Parse it, right? Sorry. Yeah, it takes a token.t. Well, no, it takes a token.t. So what's wrong with, so was it line 50? Operator not. Keyword. Uh, this expression is type bool. Oh yeah, I need to convert it back. Whoopsie. So evaluator 32. Bool as floats. Yeah. Unless I can just, I could definitely abstract this, but it's not worth it for such a small use case. So let's just do this. I was so close to making no mistakes, and then my brain just glitched. Okay, that should work. XOR, unbound value. LOR or LXOR. Well, yeah, what the hell is this then? Huh? Wait, can I do this? No way. Okay, okay, well, you're not, these docs don't help me. How to do Boolean exclusive OR? Does it exist? This is provided by the not equals operator. Oh, yeah. Oh, yeah. Wait, what? Yeah, XOR is just not equals, isn't it? I mean, I knew that, but like, I never thought to apply it to programming. That's so funny. That is actually so funny. Nah, that can't be correct. There's got to be more to it than that. I mean, the difference is that you are only working with binary values, but damn. Okay, there you go, trifecta. So XOR will be different from not equals in that, in fact, I don't even have not equals, do I? And I didn't add it. Um, I should probably add it. Nah, I said I can't be bothered, can I? Yeah. Test. I might add it later. Let's see. But the difference is that XOR will convert to booleans, and oh, 5 equals 3, expected 0, receives 1. 5 equals 3. The rest passed, right? Okay, so these two failed. 5 equals 3 is returning true. 5 equals 5, 5 equals 3. Why is 5 equals 3 returning true? Um, float as bool x equals float as bool y. So left side equals right side. Float as bool x. Because it's not a Boolean operator. Aye, aye, aye. My bad. So I'll just do it like this. Yep. This is fine. These are Boolean operators and an OR. Like 5 and 3 should be fine. XOR should be fine. It's just equals that should be like that. Okay. Let's have a look then. Malware scam reported on VS Code. What? 5 equals 5. Expected 1, receives 0. What? 5 does not equals 5. Right, sorry, this is strict. I'm using the strict equality operator. God, this language is just full of joy, full of joy and whimsy. Okay, that should work. Awesome. So let's run it. 5 equals 5 is 1. So yeah, cool. 5 and 2. 5 and 2. That's an error. Let me just hide this verbose output. It's kind of peeing me off. Let's go boom, 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 boom. Well, first, clear. Okay. What's like a classic example of actual Boolean arithmetic here? Um, let's say x is our length. Let's say x is a pointer. Right now it's null, and we want to check if x is not null, we want it to if x is not null, we want to take the pointer address and I'm trying to think what an actual application is here. Um, if it's not null, we want to. Yeah, I can't think of any use case. Whatever. X times 5, 0. X and 5 times 5 between brackets. Yay! But if I change it now to x to like 23, then the same thing will give me 5. Awesome. 5 was 5, it's true. So I can do like does 5 plus does 2 plus 3 equal 3 plus 2? The commutative property or whatever. I think that's or maybe associative property. Um, okay. Here's an actual application. Let's say I have a quadratic formula. So x squared. Come on, Kojo. Fucking math. Negative. Do you add it or do you minus them? I can't remember. Okay, I'm minus 3x times x. I have to do plus 2. So if I define x, sorry, equals 0. So if I define x as -1, I made this so much harder than I needed to. It's false. Yeah. Okay, forget that. Let's start anew. Let's say I have the quadratic formula. X squared we'll make our x's 4 and 2. So, no, 4 and 3. So plus 12 times x, 12x, plus, no, you add it here. God damn, I'm rusty. 7x plus 12 equals 0. Okay, so if I define x as 2, then this is going to be false. But if I define x as 3, which is one of the roots of this equation, I should get 1. Unless I suck and I don't know how to do math. 3, or is it -3? It's -7, isn't it? I think it is -7. -7. Yes. And then if I do x is 4, which is the other root, this should also be 1. If I do x as 2, this should be false. Yay! There we go. Application reached. So done. I've added Boolean logic. So git commit m. Oh, I forgot to test one actually. How about not? Not 5 equals 3. Okay, that's it. I git add, git commit, add Boolean operators, and push. Awesome. Awesome, awesome, awesome. In less than 3 hours. Done so much. So that's it, really, that I can think of to add right now. I could add not equals, but I cannot be bothered. Just do not and then wrap it in equals. Or rather, I don't want to deal with the font not liking me. Oh, one issue actually. If I, yeah, so my tests, eval test error. This should be an error. If I try to assign to and, I should get an error. So and 5. Okay. It knows it's a keyword. That's good. That's good. Okay. That's fine then, I guess. So if I try to June test this, I should get no errors. Yep. So again, git add, git commit, add test to make sure assigning to a keyword results in an error, and then push that. Yeah, so that's all I can think of to add for, in terms of operators. So then the only other thing to add is, well, there's two things I was thinking actually. One is chaining, to add chaining. So if you reach a semicolon, you can do like, you can do, okay, like this, x to 5, and then like x plus 3, and it'll return this. Or like x5, y3, x plus y. Like I want this to be able to happen as well. I think that'd be cool, a cool feature to add. And also functions, right? So for functions, there are two ways we could do functions. We could do the cosine of like also like degrees and radians. Oh boy, to have that conversion. But like let's say cosine of pi, pi over 2, which would look like this anyway. I could do like this, or I could do function call. Now this is a great example because it just doesn't show you. Okay, so let's say cosine of pi. We could do this like Haskell style, OCaml style, or we could do C style and also math style function call like this. Also, you can't do 5x, can you? It'd be cool if like 5x became 5 times x. So if you had a number followed by an identifier, it would multiply it. That'd be cool as well. But only if it's a non-keyword, obviously. Like 5 and 2. Actually, I guess there's no reason this shouldn't work either, right? I could make this work. Yeah. So two things I want to do then. I want to have this, and I want to have this, and I want to have function calls. For function calls, I parse the identifier, and then I check if the next token is a bracket, I guess. Um, the issue there is that if I have like x 3 plus 2, like this would be read by a human as x times 3 plus 2, right? So, and like you could argue that you should be able to do cosine of like 50 as well. Yeah. I mean, I can make it like special. Like I could check the case. Hmm. Thing is, this would be treated as a as one variable, which I do not want. And the only way to circumvent that is to have a list of functions. When I have an identifier, check if it's a function. But then the issue is, if I allow user-defined functions, I could literally have a function called cosine 50, and then what? Multiply it by 50? Like that's not, or like apply to 50. This just looks weird. This would be probably best. Question is though, how do I do this? Right? How do I do that? So parse the keyword. If there's a bracket afterwards, check if it's a function. If it is a function, like if the function exists, then by the way, this is now on the parsing stage. So if the function exists, then parse this as a function identifier, and then these as arguments. So look for the closing brace, and then just parse these as things, and treat each branch of this as their own expression. So you can have like 5 plus 2, yeah. And then if the function doesn't exist, then treat it as a variable, and then just treat these as normal brackets and multiply. And then if there's a comma, then that'll just cause a normal syntax error. Okay, like this, exactly, invalid token. Um, by the way, can I do this? No, of course not. It's a token failure. I mean, it's a parser failure. Okay. How about X? This also is a parsing failure, right? Okay, that too. But if I yeah, that's fine. Okay. So these are definitely cool features I want to add. But I'm gonna stop now to take a break. I might implement these today, or I might come back to it tomorrow. But either way, thanks for watching this video so far, Oh wait, I'm not done yet. I need to actually document my changes. So read me, please. And then we can also go over what we did actually. So there are quite a few operators defined in the defined for this calculator. Quite a few binary operators. Yeah. Additionally, subexpressions can be wrapped in parentheses. So I'll just do this. So we've got addition, subtraction, multiplication, division, negation, negative a. Let me just check my list. Parser, please. Exponentiate as well. Percentage. Okay, let me delete those. Hook this and hook my readme. Okay, so got negation, exponentiation. So a to the power of b. We got percentage. So a percent, which equals a times a divided by 100, sorry. Factorial, just a factorial, which equals a times a minus 1 times dot 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 times 1. Not, and then all the binary operators, right? Yep, so equals a equals b, not a, and a and b, or a or b, XOR a XOR b. Yeah, that's it, right? Okay, we go variables, constants, and did I add anything else? Right? That's it, right? Let me check my tests because they will say. Yeah, that's it. Cool. So then, cool. I actually like this so far. I mean, I was like, it's only been like 3 days, by the way, of me recording this. Of me recording this, right? I think. But like, yeah, I feel like I'm really getting used to OCaml now. And although I still don't prefer it to Rust, like I still look forward to eventually doing this in Rust. It certainly is workable. It's certainly workable. I do like it. But I guess I'll add. Oh, I should probably specify. Um, the Boolean operators will treat any non-zero value as true and 0 as false. And will return and will output 1 for true and 0 for 1. And 0 for false. 0 for 1. What? This should be in backticks. As should this. As of present, there are no true or false keywords. Although it is possible to user define these. You know, screw that. I'm actually going to add them as constants. The hashtag constants. Can I do that as a link? The constants true and false evaluate to 1 and 0 respectively. Also. So let's just add this then. So in our constants, true, I should put at the top because it's quite significant. It's just 1 and false is 0. So then in my tests, just add these here. Eval test okay, true should be 1 and false should be 0. And then that actually means that down here I can replace these with their proper things. So true and true, true and false, true, false, false and false. Yeah, this is going to take a while. Let me just do this. This line, 0, put it false, please. Same thing again, please. Boom, boom. I have to do one by one because I can't change the number at the end. Okay. I'll keep that one as 0 actually. 1 or false, false or 1. Okay, and then say for true, the 1, so replace 1 with true. Yep. Okay, let's test. Works. Nice. So if I just try to myself actually, manually. Why does it recompile? True, false, true and false. False, obviously. Not true is 0. Not false is 1. Cool. Yep. Sound. So just go ahead and get this. Add true and false constants. And then back to my README. Yep. So true equals, so true equals 1. False equals 0. This is redundant. I'll just put this in brackets here. And then also move it here. Okay. Nice. That's it, right? I think that's it. So git add update with update docs with booleans, boolean operator with new operations script. It should be self-evident by the diff, the git diff, what the differences are. Notification. Yeah, what's this then? Emergency update needed. High risk threat. Good thing I don't use VS Code. Malware scan reported. Okay, well, it hasn't been picked up, so hopefully it's actually legit and not a scam. This is just like a virus malware thing. Cool, that works. The link works. For some reason, I don't see my thing here though. Did I not push? Reload. There you go. True, false. It's all there. Variables. I totally forgot that this is not. That's fine. Okay, so I want to also add notes for what I want to do next. So TBA. I don't guarantee I'll add these, but some features I'm thinking of adding are, yeah, so what do I say? There's quite a bit there actually. More constants? Like physics constants, I guess. More constants, probably primarily from physics, since it has a lot. Functions, both built in and user defined. Yeah, user defined functions shouldn't be too hard. Saying that though, I have to do like, how would I have users declare it? Should I add let statements? I think I might need to add let statements at some point. I'll think about it. Is that it? Constants, functions, chaining commands via semicolon. Makes sense. I mean, I could do a different command like this to chain, but I feel like a semicolon is just a bit expected. Or some other operator. Looks schmexy. Oh, I also need to add greater than and equals greater than less than. Whoops. Ordering operators, boolean operators. Less than equal to, greater than, and greater equal to. How did I forget? Yeah, I just forgot to add those. Those would be really easy to add. Just need to do it. Okay. Was that it? So it was chaining, functions, more constants. I thought there's something else. Like if I look at my calculator. Oh. Implicit multiplication for numbers next to variables, i.e. 5x equals 5 times x. Yeah, that'd be cool to add if I can, since it is a calculator. Obviously I wouldn't do this for a programming language, but for a calculator, yeah, absolutely. Cool. So git adds, git commit, just update docs. Update with adds TBA features, which sounds a bit weird. Adds to be added features. Okay. Sick. So I'm not going to release this yet. Actually, I'm going to release this. So let's do a new release. To make sure to actually compile what I have so far. Okay. Also, I should really add like a proper quit feature, but whatever. So this is more operators, constants, and more operators. Is that it? Yep. Yep. Added constants, which okay, added the 4 constants: true, false, pi, and e. Added the operators exponentiation or exponentiate, percent, factorial. I said it had mod as well, right? Modulo. But I don't know if I want to be honest. Factorial equals and not and or XOR. That's it. Yeah. So that's all I did, right? Yeah. That should be it. Okay. Attach binaries. So programming projects. Bam. Build defaults. Bin. Main. I mean, I did tests, I guess, but that doesn't really count. The users don't care about that. Calculator.exe. Set as latest release. Select tag. New tag. 1.2.0. Okay. Cool. Woo! So there you go. That's kind of cool. Adds a lot of these things. We can check the lib. And we can see everything coming together. So beautiful. Tears to my eyes. Wow, this syntax highlighting is cooked. What the hell? My strings are grey. Yeah. All right then. I will return to this whenever I decide to return to this. Otherwise, subscribe so you don't miss out the video when it comes out. I think my mic's getting like really quiet. Like I could talk this closely and it won't even get that loud. Hopefully that's okay though. I'm have to look into fixing something. Is that better? Is that better? Is that better? I don't know. Anyway, yeah. So yeah, if you want to, again, go check out the project. It's in the links in the description, and yeah, just subscribe if you want to see more progress or see me do more progress. If you watch a whole 3 hours, I'd be surprised if you did. But if you skip to the end, whatever, I will be making more videos like this.